Welcome to this webinar, where I'll run you through our AEC Hackathon project from the 2020 AEC Hackathon in Copenhagen that was held in February. We won Best Overall Project with our Digital Twin for Everyone proposal. My name is David Fink, and I am the Digital Manager at Henning Larsen Architects. I'm really excited to be here today to tell you the story of our Hackathon project. We had been looking into digital twins to find out how we could build one of our own and find out what the benefits of the digital twin could be. For those of you who are not familiar with digital twins, they are basically a bridge between the digital and physical worlds. Data received from sensors are sent to a digital storage platform where the data is linked to the digital representation of a physical asset. The data is interpreted and visualized on a dashboard and sent back to the physical world's information. One of the biggest issues with digital twins is the data. It can be like pounding a square peg into a round hole. The data is often unstructured or not structured in a format that's usable. You may not have access to the data, as the data may be stored in closed systems. The data sources may not be compatible. It can take a lot of effort to align the data, reformat it, and organize the data to make it useful. So one of our goals was to try and take this fragmented data and align it and make it useful. Our idea was to build a bridge between the physical and the digital worlds where data could be captured from the physical world with sensors. The data would then be stored in some kind of centralized database, preferably in the cloud, and then the data would be visualized over the digital model of the physical asset and through a dashboard. This visualization of the data would then close the loop back to the physical world where the data could be reacted upon by the end user of the building or the spaces. By placing sensors in the physical world, the building and spaces we use daily, and recording data in a structured database, it could then be possible to feed the data into the digital representation of the physical asset. The data can then be visualized in dashboards to inform the user of how the asset is performing. The end user would then have a better understanding of how their asset is functioning and how they can improve its performance. After there's enough data recorded, machine learning could be used to make informed decisions so the system could make recommendations rather than control the systems, since the existing systems do not have automatic controls. When we looked into digital twins, we noticed that they were always being associated with new buildings with BMS systems that were designed into the building from the early design stages. We asked the question, is it possible to make a digital twin for an existing building? Buildings where there is no BMS system, likely no 3D documentation, or in a lot of cases, not even any 2D documentation. The systems of these buildings are fairly simple, and the users and not the facilities management teams are controlling them. How can we create the flow of data between the physical and virtual worlds if we wanted everyone to be able to have an influence on their buildings through data received through sensors within the building? When we looked into digital twins, we noticed that they were always being associated with new buildings with BMS systems that were designed into the building from the very early design stages. We asked the question, is it possible to make a digital twin for an existing building? Buildings where there are no BMS systems, where the systems are very simple, where they are manually controlled by the users and not facilities management teams. How can we create this flow of data between the physical and virtual worlds where there is no digital data to start with? And how can we give everybody the possibility of having their own digital twin? So we were looking at something that was scalable. We were looking at an individual building where the same system could be duplicated multiple times to multiple users and multiple owners. At the hackathon, we went into the lightning rounds and pitched the idea of how we can make digital twins available to everyone. We knew that digital twins were a high-level concept, but how can we bring this concept of digital twin down to a level where everyone can understand it and take advantage of it? We made a poster and further defined what we were trying to achieve. Since our pitch was very short, we further developed the concept on the poster. From here, we started to assemble our team. One of the first people we met was Pedro. He came with some sensors that could pick up traffic from mobile devices, but he did not have a use for them. His sensors could measure how many mobile devices were within range of the sensors. He was hoping to code them to place the owners of the devices in the space based on the signal strength, using triangulation. This turned out to be much more complex since each person could have multiple devices and all the devices have different signal strengths. This seemed like a good match for us, so we added him to the team. We built up the rest of the team with some engineers from Ramble, as well as students from the Architectural Academy in Copenhagen and the Copenhagen School of Design and Technology. After we formed the team, we evaluated our skills we had, and we were off to try and come up with a proposal within the next 2 days. We found our space in the Blocks Hub and started getting to work to define the idea and making a plan for the next 48 hours. We knew from the start we would not be able to do everything we wanted, so we started to limit the scope of the project to get to the core of the idea so we could get the concept across and hopefully getting a working prototype together. We divided the work into sections so we could take advantage of all the skills we had available on the team. We divided the team into developing building sensors, coding the sensors, developing the building model of the Blocks Hub, coding the interface, building the database, creating the dashboard. There was no shortage of tasks, but there was definitely a shortage of time. We realized we needed some extra help, so we tapped in some of the resources from Autodesk that were available at the hackathon. They helped us get started using Forge for accessing the data from the database, visualizing it with the model, and creating some of the dashboards. After everyone started working on their assigned tasks, the solution began to take shape. The sensors we built on top of Arduino microcomputers started producing data. The data was being stored in the database. We could see that the solution is beginning to take shape. There were other teams we started collaborations with. One of the teams was building mood. Their idea was to use data from sensors to interpret the mood of a building. Was it a good place to be or a bad place to be? And they needed data. We had data, so we decided that they could take advantage of the data that we were producing to use on their project as well. To demonstrate the concept, we needed more data to show how the system could work. So we were trying to get the sensors to run overnight. So we placed the sensors around the members lounge in the Block Hub. The sensors were working great. They were receiving data and they were transmitting data to the database. But shortly after we left for the evening, they stopped working. This was the evening before we needed to present, so we panicked a little bit. We managed to get the sensors working again, but still needed to get the interface with the model and the dashboard to work. In the system, we would not build our own sensors. We would use off-the-shelf sensors that had open source data available from them so we could link them into the interface, and we weren't working in closed systems. Since we were still having trouble getting the interface to work, we started to look into Rhino to visualize the data as a fallback plan. So the Rhino and Grasshopper scripts could read the data from the database and visualize it. But this wasn't the solution we were after. Literally minutes before the presentation started, we had the interface working. It was so soon before the presentations, this is actually the only image of the interface that we have. So the idea behind this is we had these sensors that we had set up around the Blocks Hub. They were reading temperature, humidity, and light levels and transmitting the data over Wi-Fi to the database. We had built this Forge platform on top of the database that would access the sensor information and locate the sensors in space. Through the Forge interface, you could then click on the individual sensors and see the historical data, as well as see the live data being transmitted from the sensors in the model. And this was our bridge back to the physical world. So we presented our idea and showed how the system was working and explained our concept to the judges of how we wanted to make these digital twins for everyone available. And the idea is that we would have some kind of interface where you could take sensors and you could plug the sensors into the interface and customize it to individual users. And in this way, we could get around having to get data from BMS systems, and we could customize it to each individual user. And the concept won the best overall project at the hackathon. And we're really excited and feel this is a huge privilege and gives us a huge opportunity to take this to the next level. So right now we are trying to develop a business plan. We've been a little bit delayed because of the COVID-19 crisis, but now we have regrouped the team and we're trying to say, okay, what is our business plan? What are the use cases? And what kind of business model can we have for a system like this? As well as trying to find who our target groups are and what kind of skills we need to develop the project further. And we're fortunate to have the backing of Blocks Hub with this project to try and take the hackathon project to the next level. So if you're interested in being part of our hackathon project, we're looking for some coders, IoT experts, web developers, business planners, and of course a little bit of financial support. So if you're interested, you can contact me, David Fink, or Alejandro Mata, and we can tell you more about the project and tell you how you can get involved. So thanks for listening to our story about our hackathon project from 2020, and good luck on your own hackathons. Thanks.